In Chapter 12, we've been looking at rational expressions, and now we're going to multiply and divide those rational expressions. So first of all, let's take a review of fractions, because remember that rational expressions appear like fractions. So remember that when you multiply two fractions together, we're going to multiply across the numerators and then across the denominators. So we end up with a times c in the numerator, b times d in the denominator. If you're going to divide a fraction, one method of doing this, a very common one, is to invert and then multiply, or multiply by the reciprocal. So instead of dividing by c over d, we multiply by d over c. And now again we multiply across the numerators, across the denominators. Well, it's going to work the same way with rational expressions. So here we're going to be dealing with typically polynomials, or it could be monomials, or even just single numbers. But whatever you end up with for your terms, remember to look for opportunities to cancel. So the keys here are going to be factoring and then canceling wherever possible. So let's look at some examples here where we start by finding the product. So we could just go straight ahead and multiply across the numerator if we wanted. So 3x squared times 8 is 24x squared, and then multiply across the denominators. So we have 4 times 9x cubed would give us 36x cubed. Now notice that we can simplify here, because 12 will go into both 24 and 36. It goes into 24 2 times. It goes into 36 3 times. Also, the two x's in the numerator are going to cancel 2 out of the 3 x's in the denominator. We're still going to have that 1x left by itself, and we end up with 2 over 3x. Now notice that you could have done some canceling right away. So for example, if we look at writing this again, 3x squared over 4 times 8 over 9x cubed, okay, we can look go ahead and look across that multiplication and still look at numerator here compared to denominator here. And I see that 3 goes into 9. So I'm going to cancel the 3. 3 goes into 3 once, 3 goes into 9 3 times. Likewise, we still have that same story with the x's. These two x's will cancel 2 out of the 3 x's here. We still have 1 left. And then the 4 and 8. 4 goes into 4 once, 4 goes into 8 twice. And now we have a lot simpler expressions to multiply. So now we have 1 times 2 in the numerator and 1 times 3x in the denominator. Notice it turns out the same. So whichever you prefer, go ahead and multiply right away or do some canceling first. And here we have 4h times 3 over 8h cubed. If you want, you can write this as 4h over 1. And we're still looking for some canceling wherever possible. So 4 will go into 8. So we go ahead and say that 4 goes into 4 once, 4 goes into 8 2 times, and then this 1h will cancel one of the 3 h's here. We still have 2 h's remaining. So now we can go ahead and multiply. 1 times 3 is 3, and 1 times 2h squared is 2h squared. Okay, number 3. Here we want to see if we can do some factoring. So we have y squared minus 25 over 2y squared times 3y over 5 minus y. Notice this is the difference of two perfect squares. So we can factor that out to y plus 5, y minus 5 over 2y squared times 3y over 5 minus y. You know, here's a little trick, because if you notice here, y minus 5 and 5 minus y are really doggone close to each other, right? The difference is here the y is positive and the 5 is negative. That gets reversed here. The 5 is positive and the y is negative. But we have a little trick we can use, which is this. If you multiply negative 1 times 5 minus y, you're going to end up with negative 1 times 5 is negative 5, and then negative 1 times negative y is a positive y, which is the same thing as, reverse the order, it's a positive y and a negative 5. So it's y minus 5. So when you get a subtraction here and you see a difference but the terms are in opposite order, you can put them in the same order by multiplying one of those two expressions by negative 1. And you can get away with that as long as you also multiply the other side, in this case the numerator, by negative 1. Okay, so when we multiply this by negative 1, we are going to end up with, let me rewrite it down here, we end up with y plus 5 times y minus 5 over 2y squared times, and now instead of a 3y it becomes a negative 3y, and now instead of 5 minus y, multiplying by negative 1 will give us y minus 5. And now we can do some nice canceling, because this binomial y minus 5 cancels this y minus 5. Okay, so this is a factor. This is a factor. They're the same, so they cancel. Also, we can cancel this y, which will cancel one of the two y's here. And now we finally multiply across, and we have y plus 5 times negative 3 over 2y times 1, which is just 2y. Now, I would be fine with seeing the answer like this. There's no more simplifying that you can do. In some cases, though, especially if you're looking at a multiple choice question on a mastery check or a test, you might see somebody go ahead and distribute that negative 3. So you could see this as negative 3y minus 15 over 2y. So this is an OR. So either one of these would work for me. Be prepared to deal with either one in case you have a multiple choice question. Hey, number 4. Here we have a trinomial, a binomial, a binomial. What we want to do is factor wherever possible. R squared minus 12r plus 20 will factor into r minus 2 times r minus 10. Okay, and if you want to go back to using the x, you would have 20 here and negative 12 here, which is going to give us a negative 10 and a negative 2. Okay, so r minus 2 times r minus 10 all over r plus 6 times, and now we have 20 over, and notice that we can factor out a 5 here because 5 goes into both 5r and 10. So we end up with 5 parentheses r minus 2. And now we can do some canceling. We have an r minus 2 here will cancel this r minus 2. Also, we have 5 goes into 20, so we can do some canceling here. 5 goes into 5 once, 5 goes into 20 4 times. Now we can multiply across, and we have r minus 10 times 4, the 4 is in the numerator here, over r plus 6 times 1. So we can just leave it r plus 6. And again, you could leave it like this, or you could go ahead and distribute the 4 and say that it's 4r minus 40 over r plus 6. And there's no more simplifying that we can do here. Hey, number 5, find the quotient. So now in the next two examples, we're going to be doing division. Remember, the key is to invert this and then multiply. So this is going to be equal to v squared, whoops, that's a squared, minus 8v plus 16 over 3 times, so instead of dividing, we multiply, but by the inverse here, the reciprocal. So 5 over v squared minus 16. Now we look and see if we can factor. And sure enough, we can. This is a perfect square. This is v minus 4 squared over 3 times 5 over, and now we have a difference of 2 squares, so this will be v plus 4 times v minus 4. And we can do some canceling, because here we have v minus 4 showing up twice, here it shows up once. So the v minus 4 here will cancel one of the two in the numerator here. We still have that one v minus 4 though. So now we can take v minus 4 to the first power times 5 over 3 times v plus 4. There's no more simplifying that we can do here in terms of canceling. We can't factor anything more. The only other thing we could do is, again, in some cases you'll see people go ahead and multiply this out. So they would write this as 5v minus 20 over 3v plus 12. Again, personally, I would go ahead and just leave it like this, but be prepared to deal with that in case you see this in a multiple choice question. Okay, number 6. Again, we have division, so I'm going to go ahead and write this out again. K squared minus 3k minus 10 over 3k squared minus 75. But now multiply by the reciprocal. So 5 over k squared plus 5k plus 6. And now we factor if possible. And sure enough, conveniently enough, we can factor. This is equal to k minus 5 times k plus 2. And we can also factor out a 3 here in the denominator. This is equal to 3 times k squared minus 25 times 5 over, and now we can factor this as well. This is k plus 2 times k plus 3. And we can do even a little more factoring here, because here we have a difference of 2 perfect squares. So this is equal to k minus 5 times k plus 5, k plus 2, let me erase that. K minus 5 times k plus 2 over 3 times k plus 5, k minus 5. There's our difference of 2 perfect squares factored out, times 5 over k plus 2 times k plus 3. And now we look for canceling. So here we have a k minus 5. We'll cancel this k minus 5. And here we have a k plus 2 cancels this k plus 2. And that's going to be all the canceling that we can do. So we end up with 5 by itself in the numerator, and then in the denominator 3 times k plus 5 times k plus 3. And again, I would leave it like this personally. Just be prepared in case you get a multiple choice question where the answer would multiply this out. So you could multiply k plus 5 times k plus 3, multiply that all by 3, and you'll end up with an equivalent answer. So there you go with multiplying and dividing rational expressions. Good luck.